Welcome back to the Deep Dive. Today, we are not just talking about a news headline. We really are talking about a genuine pivot point in history,
Yeah.
really.
Yeah, that's not an exaggeration.
No, it isn't. We're unpacking a story that sounds like it was ripped straight out of a cyberpunk thriller. A high-stakes spy novel. But this is real life, and the verdict just came down this week.
It's a massive story. It really is one of those rare moments where the legal system, the absolute cutting edge of the tech world, and some very heavy-duty geopolitics all just crash into each other at full speed.
Exactly. We're looking at the breaking news from January 29, 2026. A federal jury has delivered the first ever conviction for AI-related economic espionage in United States history.
The first ever. That's a huge deal.
A huge deal. And just to set the stage here, we aren't talking about, a small startup getting their marketing plan copied or something. We are talking about Google. We are talking about the theft of the absolute crown jewels of their artificial intelligence infrastructure.
That's right. And I think crown jewels is actually the perfect term here. It's what the prosecutors used, and it's dead on. This isn't just about stealing a few lines of code for a consumer chatbot.
No.
This is about national security. It's about 14 criminal counts, a secret double life, and a theft that could have allowed competitors, and specifically foreign entities, to leapfrog billions of dollars in research and development.
It's the high-stakes race to dominate artificial intelligence playing out in a federal courtroom. It's incredible. So today, we're going to look at the man behind it all, Linwei Ding, also known as Leon Ding. We're going to look at what he stole, how he stole it, and frankly, why this changes everything for how companies protect their ideas from now on.
It absolutely sets a precedent that is going to ripple through every boardroom and every research lab in Silicon Valley and really far beyond. This is the wake-up call that the industry has been, both dreading and kind of expecting.
That's a good way to put it. Okay, before we fully unpack this espionage thriller, I want to mention that today's deep dive is brought to you by pressreleasecloud.io.
Great folks over there.
They really are. In a world where news moves this fast, look at this verdict. It's historic. You need experts to handle your content creation and distribution. Pressreleasecloud.io are the people who help get critical news out to the world effectively and quickly. So if you have a story that needs to be heard, check them out.
Communication is key,
Okay.
especially when the landscape is shifting this quickly. You have to control the narrative.
Absolutely. Okay, let's dive into this. We have to start with the protagonist, or I guess more accurately, the antagonist of this story, who is Linwei Ding. Because on paper, he looks like a classic success story.
He does. Linwei Ding, also known as Leon, is a 38-year-old software engineer, and it's really crucial to understand his standing within the company. There's a tendency to think of insider threats as, some disgruntled, low-level employee or maybe an intern who stumbled onto a server they shouldn't have access to. That is not this case, not at all.
Right. He wasn't fixing bugs on the search bar or, updating the Google Doodle.
Far from it. He was hired by Google back in 2019 to work in their supercomputing data centers division. Now, supercomputing is a buzzword we hear a lot, but in the context of Google, this is the elite of the elite.
Supercomputing data centers. That sounds heavy. Unpack that for us. What does a software engineer in that division actually do?
It is the heavy lifting. Think of it this way. Everyone talks about the AI models, right?
Sure, the chatbots, the image generators.
Exactly. The things you and I use on our phones. That's the software you see. It's the user interface. But Ding was working on the infrastructure that makes all that software possible. He had access to the backbone of Google's entire AI operation.
Could you use a car analogy? Because I love a good car analogy.
I do.
He wasn't working on the paint job or the stereo system.
No, he was engineering the secret engine that makes the car faster than anything else on the track. Actually, to take that analogy even further, he wasn't just working on the engine, he was working on the factory that builds the engine.
Oh, okay.
He was dealing with custom-designed hardware and networking configurations. This is the stuff that allows Google to process these massive, almost incomprehensible amounts of data faster and more efficiently than its competitors. It's the secret sauce of their computational power.
And that distinction is just so vital. He wasn't building the product. He was building the capacity to build the product.
Exactly. And that position requires a massive, massive amount of trust. You don't give the keys to the secret engine factory to just anyone. You're talking about proprietary technology that Google has spent over a decade and, billions and billions of dollars refining.
And that trust is central to the betrayal here. I mean, it's the core of the story. Because while Ding was sitting at his desk at Google collecting I'm sure, very sizable salary from an American tech giant, he was living a complete double life. This is where the story just gets wild. It wasn't just that he was disgruntled or looking for a new job.
No, this wasn't a rage quit situation where he just grabbed some files on his way out the door. Prosecutors proved that while he was employed at Google, he was secretly the chief technology officer, the CTO of one Chinese tech company.
Okay, which is already a huge conflict of interest.
A massive one. And if that wasn't enough, he was also the founder of a second Chinese tech company.
Wait, hold on. He's working full-time at Google in the U.S., presumably clocking in, attending meetings, drinking the micro kitchen coffee.
All of it.
And simultaneously, he's a CTO and a founder of companies in China. I mean, how does someone even manage that schedule? Forget the espionage for a second. That's just impressive time management.
That's the million-dollar question, isn't it? But he wasn't just, moonlighting to make some extra cash or coding a little side project on the weekends. He was actively pitching investors in China. There's evidence, emails, and presentations where he is claiming he could replicate Google's AI supercomputing technology. He was using his access at Google as his primary value proposition to these investors.
That is just incredibly bold. He's basically saying, invest in me because I have the blueprints to the Google Death Star.
That is essentially the pitch. I can build you what Google has, and I can do it right now for a fraction of the cost because I don't have to do the R&D. And the timeline is just damning. The theft ran systematically from May 2022 to April 2023.
A full year.
A full year. This wasn't a one-time lapse in judgment where he copied a file he shouldn't have. This was a premeditated year-long operation to siphon off critical data.
So let's talk about that data. Let's get into the specifics of what was taken, because I think there is a huge misconception when people hear stealing AI secrets. They imagine he put the code for, Gemini or some other chatbot on a thumb drive.
Right.
But you mentioned earlier, this wasn't just code.
It goes so much deeper than code. The trial revealed he stole over 2,000 pages of proprietary documents. And the expert testimony during the trial really highlighted that this was about infrastructure. It's so important to clarify this because the general public thinks AI is just, software, a clever algorithm. But at Google's scale, AI is hardware. It is physics. It's about managing heat and the speed of light.
Right, so let's break down the stolen jewels, as we're calling them. There were really three main components here that stood out in the trial. The first one, and maybe the most famous, is the chips.
The TPUs, tensor processing units.
Okay, let's unpack that.
Yeah.
I think most of our listeners know what a CPU is, the chip in your laptop. We know GPUs are for graphics and gaming and have become essential for AI. What is a TPU and why is it worth risking, decades in prison to steal?
It's a great question. So a CPU is a jack of all trades. It does everything okay. It's a generalist. A GPU, as you said, is great for parallel processing, which is why it's been the go-to for AI training for years. But a TPU is a custom chip designed by Google, for Google, specifically for machine learning.
So you can't just buy one?
No, it's not something you can buy off the shelf at Best Buy. You can't even buy them from NVIDIA, who dominate the GPU market. Google spent billions developing these to be hyper-efficient at the specific kind of math matrix multiplication, mostly, that is the bedrock of AI.
Okay, so it's like a custom-built engine for a Formula One car versus a stock engine in a sedan. It's purpose-built for one thing and one thing only.
Yeah.
In-scene speed and AI training.
Exactly. It's an ASIC, an application-specific integrated circuit. But here is the critical part, and this is where the espionage gets really, really specific. What Ding stole wasn't just the final design. It included the circuit designs and what the court documents called the proprietary architectural decisions behind these chips.
Architectural decisions. That sounds interesting, but also a bit vague. Why is that specific phrase so important? Why not just steal the final schematic?
Because the architectural decisions explain the why behind the design. If you just steal the blueprints, you see what they built, you see the final product. But if you steal the documents explaining the architectural decisions, you see the entire evolution of their design philosophy.
Okay.
You see the experiments they ran. You see the trade-offs they made between heat, speed, and power consumption. And crucially, you see what failed.
That's the key, isn't it? The negative knowledge.
Exactly. It's the most valuable thing. If you know what doesn't work, you save yourself years of trial and error. You save literally billions of dollars in R&D because You don't have to go down all those dead-end paths that Google already explored and paid for. You can just skip straight to the solution that Google spent a decade and a fortune refining.
That's the leapfrog effect we mentioned.
Yeah.
You aren't just catching up, you are skipping the entire painful, expensive, difficult part of the race. It's like stealing the answers to the tests, but also stealing the teacher's complete notes on why those are the answers and why all the other answers are wrong.
Precisely. You are standing on the shoulders of giants without asking permission. And that was just the first component. The second major component he stole was, for lack of a better term, the nervous system, the networking.
Right, the interconnect fabrics. Now, I have to be honest, networking sounds a bit dry compared to secret superchips. Why was this considered a crown jewel?
It sounds dry, but it is arguably the most critical bottleneck in large-scale AI today. You can have the fastest chips in the world, but AI training happens across thousands, sometimes tens of thousands of chips simultaneously. If chip A finishes a calculation but has to wait even a few milliseconds to tell chip B what it did,
Your supercomputer's just sitting there, burning power, doing nothing.
exactly. Your multi-billion-dollar machine is sitting idle. Latency is the enemy. If the chips can't talk to each other almost instantly, your AI is slow. We are talking about training models that run for weeks across entire warehouses full of chips. Google has developed proprietary protocols, special cabling, custom-designed optical switches to make sure those chips are communicating at nearly the speed of light.
So it's like having a team of geniuses, but if they can only communicate by, I don't know, carrier pigeon, they aren't going to solve the problem very fast.
That's a great analogy.
Google built a telepathy network for their chips.
They essentially did. And Ding stole the secrets of how Google scales this across massive clusters. He stole the interconnect fabric specifications, the network topology, everything. This is incredibly hard engineering. It's physics again, dealing with light speed limitations and managing the insane heat generated by all that high-speed communication.
Which again allows a competitor to design a data center that functions like Google's without having to spend years and fortunes figuring out the incredibly complex logistics themselves.
Correct. And then the third component, which ties it all together, was the software stack.
Yeah.
Specifically, the workload schedulers and resource allocation algorithms.
The brain of the operation.
That's a perfect way to put it. If the chips are the muscles and the network is the nervous system, this software is the brain. It's the conductor of the orchestra. It tells the muscles when to move and how. It manages heat. It manages energy efficiency. It decides which chip gets which math problem at which exact microsecond to ensure maximum utilization.
And efficiency is money in this game. Big money.
It's everything. These data centers consume the power of small cities. The electricity bills are astronomical. If your software can make the whole operation just 10% more efficient, that's millions and millions of dollars saved in electricity alone, not to mention you get your AI models trained faster, which means you get your products to market faster.
So Ding took the blueprints for all of it. The muscles, the nervous system, and the brain. The hardware, the network, and the management software. He took the whole package.
The whole kit.
It's just devastating when you look at it that way. It's a complete starter kit for building a world-class AI supercomputer. So the next question is obvious. How? I mean, how do you walk out of Google, one of the most secure, tech-savvy companies on the planet, with 2,000 pages of the most sensitive documents on Earth?
Was he like walking out with boxes of paper?
No. And this is where the modern nature of the crime really comes in. It wasn't a smash and grab. He didn't break a window and run with a server. It was a slow drip.
A slow drip. Explain the mechanics of that.
So he started in May of 2022. He began systematically copying files from Google's internal source code repositories. But here's the trick, and it's either brilliant or just incredibly audacious. He transferred them to personal cloud accounts, specifically Google Cloud account.
Wait. He used Google's own product to steal from Google? That seems completely counterintuitive. Wouldn't they see that immediately?
You'd think so, right?
Yeah.
But ironically, it's very clever camouflage if you think about it.
That's so. He's a Google engineer. He's on Google networks all day long. His job requires him to interact with Google Cloud all day for legitimate work. So traffic going to Google Cloud from his work machine doesn't look inherently suspicious in the security logs. It just looks like work.
It's the needle in a haystack problem. He hid the stolen data inside the massive, overwhelming stream of legitimate data.
Exactly. It created a massive challenge for their security systems. It looked like legitimate work activity, or at the very least, it was incredibly hard to distinguish from it. He also used specific methods to avoid what the security world calls detection latency.
Detection latency, is that like pacing yourself so you don't get caught?
Precisely. It means he didn't try to download 2,000 files in 1 hour. That would trigger an alarm immediately. Bells go off, accounts get locked down. He did it over the course of a year. A few files here, a document there. He disguised the activity, kept it below the radar of the automated security thresholds that are looking for big, sudden spikes in activity.
That implies a level of patience and discipline that is actually kind of chilling. He was playing the long game.
It does, and there's another detail that came out in the trial that really nailed him on the intent part of the charges. The transfers were coordinated.
Coordinated how?
With who? With his own companies in China. The timeline of his data theft from Google aligned perfectly with the development milestones of his Chinese companies.
No way.
Yes. When his startup in China needed to show progress on a specific type of technology to investors, say, chip architecture, the prosecution showed that Ding would steal the relevant documents from Google that same week.
Wow. So he wasn't just hoarding data for a rainy day. He was shopping for ingredients for a specific meal he was cooking for his investors right then and there.
That's a perfect analogy. He was supplying data on a schedule. That proves he knew exactly what he was doing and who it was for. It completely destroys any argument that this was accidental or just, taking some work home to study.
So he's doing this for a year, May 2022 to April 2023. How did the house of cards finally fall? I mean, what tripped him up?
Well, eventually, the volume and the specific patterns of his access did trigger what Google's security systems call unusual access patterns.
Even the slow drip eventually fills the bucket.
Right. In early 2023, the security systems finally flagged him. Maybe he got a little greedy toward the end, maybe got a little sloppy, or maybe the aggregate amount of data just finally hit a certain threshold that a human analyst noticed.
And Google steps in.
Google launches an internal investigation. They start watching him. They see the transfers. They get their legal team involved. And in April 2023, they fired him.
And then the FBI steps in.
Then the FBI's counterintelligence and espionage division gets the call. And this is where the terminology becomes very, very important. He wasn't just charged with theft, which is a state crime. He was charged with 14 federal counts, 7 counts of trade secret theft, and 7 counts of economic espionage.
I want to pause on that because the sources made a really big deal about the economic espionage charge.
Yeah.
To the layperson, theft is theft. What is the legal and, I guess, philosophical difference between that and regular trade secret theft?
It's a huge distinction in the eyes of the law, and it really changes the gravity of the case. Trade secret theft is, at its core, I stole this valuable thing from a company. It's a corporate crime. Economic espionage under the 1996 Act requires proving that you stole the thing with the specific intent to benefit a foreign government, a foreign instrumentality, or a foreign agent.
So it's about who you're stealing for.
Precisely. That elevates it from a corporate crime to a national security issue.
It's no longer Google versus Ding. It's the United States versus Ding.
Completely. And it carries a much heavier sentence, up to 15 years per count for espionage versus 10 for trade secrets. It signals that the U.S. government views this kind of AI technology not just as a product, like a secret recipe for a soft drink, but as a strategic national asset, like a blueprint for a fighter jet.
So we get to the courtroom. The trial happens. What was the defense? I mean, they caught it with files, right?
Yeah.
The digital trail must have been completely undeniable.
They did, it was. So the defense strategy, which was led by his attorney Grant Fondo, was interesting. Since they couldn't really deny he took the files, they tried to blame the victim.
Blame Google. Seriously.
Yes. The argument was essentially, if these secrets were really so secret, why was it so easy for him to access them? Why didn't Google have better locks on the doors? They argued that Google didn't take what the law calls reasonable measures to protect the information, and therefore, under the law, it wasn't technically a trade secret.
That feels like such a Hail Mary. I didn't steal your car because you didn't lock the door. It's not a defense.
It is a Hail Mary. It's a standard defense tactic in these cases, but it rarely works when the employee has signed multiple NDAs, undergone security training, and is clearly a sophisticated actor. And the prosecution just dismantled it with one simple, powerful concept: consciousness of guilt.
Consciousness of guilt. Sounds like a legal drama title. Explain that for us.
They basically argued this. If Mr. Ding truly thought this information wasn't secret, if he genuinely thought he was allowed to have it for his own companies, why did he act like a spy?
Right.
Why did he use encrypted communications? Why did he use multiple cloud accounts to spread out the data? Why did he go to the trouble of converting some files to PDFs to try and strip the metadata and hide them? Innocent people don't usually encrypt their work files and hide them in secret folders if they think everything they're doing is above board.
That's the slam dunk moment right there. You can't argue it was open public information while you were simultaneously sneaking around in the dark to get it.
Exactly. Your own behavior betrays your intent. It shows you knew what you were doing was wrong. And the jury bought it completely. On January 29th, 2026, after a 3-week trial, they came back with a unanimous verdict. Guilty on all 14 counts.
A historic verdict.
Yay.
And I want to zoom out now because, as we said at the top of the show, this isn't just about Linwei Ding. This is about the bigger picture, the so what of it all.
The so what? Here's the AI arms race.
We hear that term a lot. It gets thrown around in the media. But this case puts a real human face on it.
It really does. We have to look at this in the broader context of the U.S. versus China technology war. Both nations and others have publicly identified artificial intelligence as the critical technology for the next century, not just for economic dominance, but for military advantage.
The sources mentioned dual-use technologies. Break that down.
Right. Dual use means it's a commercial technology that can also be used for military purposes. The very same supercomputing infrastructure that runs a consumer chatbot or optimizes ad targeting can be used to run simulations for advanced weapons systems, or to power new forms of cyber warfare, or to operate a mass surveillance state.
So if China or any foreign adversary gets Google's blueprints for this stuff, they aren't just building a better search engine.
No, they are building state power. And that brings us back to what we call the free ride effect. If a foreign entity can steal the blueprints, they skip the billions of dollars Google spent failing. They save years of time. They save a fortune in money. And they can narrow the technology gap almost instantly.
I love the question you posed in our pre-show notes. What happens when you get the blueprints without paying the bill for all the research?
Well, you destabilize the entire global market. Think about it. If one side pays for all the R&D, which is incredibly expensive, Google invests tens of billions a year, and the other side just steals the finished product, the thief has a massive competitive advantage.
They can sell cheaper, they can build faster.
Right. And it undermines the very incentive to innovate in the first place. Why would a company spend billions on R&D if they know the results are just going to be stolen? Why spend the money if you can't protect the fruits of that investment? It's a fundamental threat to the Western model of innovation.
And this brings us to what might be the most important part of this whole discussion for our listeners.
Yeah.
The massive wake-up call for the entire industry. Because if this can happen at Google...
If this can happen at Google, it can happen anywhere. That's the terrifying takeaway. Google has some of the best security engineers on the planet. They are the gold standard. They literally invented many of the security protocols the rest of the web uses today. And yet, Ding got away with this for a full year.
So what went wrong? How do you possibly fix this?
Well, it highlights what security experts call the insider threat paradox.
The paradox being?
To do his job, an engineer like Ding needed access to those files. You can't ask a brilliant engineer to build a revolutionary engine, but then lock the engine bay so he can't see inside. Innovation requires access. Information has to flow freely for collaboration and creativity to happen, but that very access creates the vulnerability.
It's a complete catch-22. You have to trust your best people to do their best work, but trusting them is what allows them to steal from you.
Exactly. So the new security playbook has to shift. It can't just be about perimeter defense anymore, building a bigger wall to keep the hackers out. It has to be about assuming the threat is already inside. It has to be about zero trust inside your own network.
What does that look like practically? I mean, for the listeners who might be running companies, whether they're tech giants or small firms, what actually changes?
It means much more granular access controls. The principle of least privilege. You only get access to the specific tiny piece of the puzzle you are working on today, and that access might expire tomorrow when your task is done.
Like a Mission Impossible message that self-destructs after you read it.
In a way, yeah. Time-limited access, just-in-time privileges. Also, much more sophisticated behavioral analytics.
Yep.
We need to use AI to catch the AI thieves.
Fighting fire with fire.
You have to. We need systems that learn what normal behavior looks like for every single employee and then flags deviations. It's not just, did he download a file, but does he usually download files at 2 a.m.? Does he usually access this particular folder? Is he suddenly downloading 50% more than his peers on the same project?
So it's about contextual awareness, not just binary rules.
Yes. And then there's the human element, which might be the biggest failure here.
The background checks.
That's the glaring one in this case, isn't it? The fact that a senior engineer at Google could also be the CEO of a company in China that is a massive failure of vetting and ongoing monitoring. Employment contracts always require you to disclose outside work and potential conflicts of interest. He obviously didn't.
But why didn't anyone notice?
Yeah.
Why didn't a simple internet search flag his name on a Chinese corporate registry?
That's the question every chief security officer is asking themselves this week. It seems like we're going to see a lot more scrutiny on that front. Who else are you working for is going to be the first question in every interview, and you better believe they're going to verify it continuously.
It also seems like that personal cloud usage is a huge deal.
A massive one. The fact that he used personal Google Cloud accounts is a huge red flag that was missed for far too long. I think you're going to see a lot more companies start blocking all personal cloud uploads from corporate networks entirely, which is, inconvenient for employees who just want to save a family photo, but it might be necessary for security.
It really is a brave new world for corporate security.
Mm-hmm.
It's not just about firewalls and antivirus anymore. It's about psychology, behavior, and constant vigilance.
And geopolitics. Every HR manager in a major tech company is now, whether they realize it or not, on the front lines of national security.
That is a very heavy thought. It puts a lot of pressure on people who just thought they were hiring good coders.
It is. But that is the reality of the AI era we're living in.
So let's wrap this up. We have a historic conviction. Linwei Ding is looking at very serious time.
He is. Theoretically, he faces up to 175 years if you stack every count maxed out.
Mm-hmm.
Realistically, based on federal sentencing guidelines, it will be much less, but it will be significant. The Department of Justice is going to want to send a very strong message with this one.
And we saved Google's crown jewels, or at least we stopped him before he could hand over the whole kingdom.
He did. The damage was contained. But I want to leave you and our listeners with one final provocative thought.
Go for it.
This whole case, this entire discussion we're having,
Sure.
It's a success story. It's a success because he was caught. We are talking about him today because he ultimately failed. But in the world of digital espionage, you usually only hear about the spies who make a mistake.
Oh, I see where you're going with this.
It just raises the obvious and, frankly, terrifying question. How many Linwei Dings are currently operating in major tech firms right now who haven't made a mistake yet? Who are smarter, more patient, and better camouflaged than he was? The ones who haven't gotten greedy and triggered the unusual access alarm.
That is a chilling thought to end on. We might only be seeing the very tip of the iceberg. The ones who weren't quite good enough at being spies.
We almost certainly are. This conviction is a victory for law enforcement, for sure. But the real war is happening in the shadows, and we just don't know how many battles we're losing quietly every single day.
Well, on that terrifying note, thank you for helping us navigate this. It's a fascinating, if slightly terrifying look at the future of tech and security.
Always a pleasure.
And a big thank you to our listeners for joining us on this deep dive. A reminder that this was brought to you by pressreleasecloud.io. Stay curious, stay informed, and for the love of data, watch your cloud uploads. We'll see you next time.